All right, so today we're going to start a new topic unit, but it's really the same. It's all the same. So before we get on to the topic of logarithms, which is going to be today's topic, maybe I'm going to explain to you why logarithms were invented. Well, logarithms were invented largely because of the long existing problem, how do you get people to do very complex calculations? So the history of logarithms, if you want to look it up, it is really, really interesting. And basically, from my understanding, is they just wanted an easy way for people to multiply. And somebody invented logarithms, and we can discuss it more when we see it in person. Or you can look it up. Really interesting. Great IA topic, perhaps. Anyways, now I'm just going to start this off by a question like 2 to the power of x is equal to 7. All right. What is the power of x? I have no idea. Let me try. So 2 to the power of 2 is 4, and 2 to the power of 3 is 8. So 2 to the power of x is equal to 7 has to be somewhere between 2 and 3. So now I can say, well, how about 2 to the power of, I don't know, 2.9? Maybe that's 7. And I could try this approach, but it's really guessing. What does logarithms enable us to do? Well, logarithms enable us to analyze exponents. So really, when we're doing logarithms, we're really going to be doing exponent work. And we have to remember the laws of exponents. All great stuff. Let's get started. So let us start this new topic by thinking of an example. Now, here I'm just going to define something. Suppose I want to rewrite b to the power of a is equal to c, and I write it in this alternative form, log b, c is equal to a. All right, so really, I'm just trying to write that so it looks like this. So I'm going to choose to evaluate log 2, 16. And we say log base 2, 16. So press pause and try to change this. Well, we can move it back and forth, can't we? Try to figure out what is the value of log 2 or log base 2, 16. All right, here we go. So what you may notice is that the base, what we call the base, is 2. And here's the argument was 16, and if you notice that was c is equal to 16. And the only part that I'm missing is really that value right there, x. So log base 2 is equal to 16. This is really just asking you 2 to the power of what is equal to 16? And that's 4. And this ends up being a constant theme throughout the unit. When we're dealing with logs, really, we're just working with exponents. Now, we choose not to write it this way too often, but it definitely helps you out to think this way. And let's try the other one. Log 10, log base 10, x is equal to 2. Well, this is my base. So base 10, the exponent is 2, is equal to x. Well, what is x? Oh, well, fair enough. X is equal to 100. So it's really just redefining what you know and maybe taking very deliberate action into rewriting it. I love logs. They're a lot of fun. Let's get started more and more. So let's consider the exponential function y is equal to c to the power of x. The inverse of this function is x is equal to c to the power of y. Now, if you recall inverse functions, right? Really, an inverse function, what does it do? It just simply switches around the x's and y's. That's one theme of them anyways. So to think of it in this way, it is very difficult. So how would you isolate y? Now, I'm going to challenge you, isolate y to one side. You would have to create a new function to do that, right? So to isolate y, we're going to introduce this notion of logarithms. B to the power of a is equal to c can be written as a logarithm in the following way. Log b, c is equal to a. Now notice, for instance, a is the exponent. So very quickly, like if it's log 10 of 100, I can ask myself, 10 to the power of what is equal to 100? Well, a would be 2 in this example. Regardless, we have to be able to move between exponential, logarithmic form very fluid. So if the exponential form is b to the power of a is equal to c, we have to have the ability to put it into logarithmic form. And it's going to take some practice. Like you're going to be learning something new. And once you get the hang of it, it is nice. Trust me. So b to the power of a is equal to c can be written as log b base b, c is equal to a. So I'm just going to start here. Change the exponential form, so exponential form, or change to exponential form. So I guess I'm given log form. So let's see if this is actually true. Log base 5 of 125 is equal to 3. Well, here, if it's written in this form, I'm going to move it back to this. 5 to the power of 3 is equal to 125. That's what it's saying. Oh my, that's true. Now let's try this one. And it's really, really good to say it aloud. Log base 3 of 1/9 is equal to negative 2. Base 3 to the power of negative 2 is indeed 1/9. Now, I think I got a little bit tricky on you here. I mixed up the order, and sometimes when I mix up the order, it makes it much more difficult. So pretty hard to look at it that way. So I've tried to train my brain to say log q of r is equal to p. Log base q of r is equal to p. So if the base is q, the exponent is p, that is equal to r. Not bad. I think I'm getting the hang of this here. Hopefully you are too. Let's move on to the next one. I'm going to change into logarithmic form now. Oh, I guess I better keep this. So 3 squared is equal to 9. To write it in log form, it would be the log. So I'm just going to write the word log. Log base 3, 9 is equal to 2. Now notice that I think it's easier to understand that 3 is called log base 3 because the base of the exponent was 3. 9, which is sometimes called the argument, is the result. And q is the exponent, or sorry, 2 is the exponent. So log base 3, 9, the result is the exponent. So again, we're just playing around with exponents, just in a weird way. So now I'm going to change this into logarithmic form. Log base 4. Argument would be 164. Maybe I'm going to put brackets in there, just to clean it up a bit. And that is equal to my exponent, -3. Now, log, I can ask myself here, what is the base? The base would be g. Log base g f is equal to h. All right. Hope that makes sense. It's kind of an interesting way to think about things. I know it's probably very hard. You may have to watch the video again and try to make sense of it. Let's continue.